Hi guys, time to talk about Chapter 5, Section 5.4, Properties for Logarithms. So there's two forms that we want to talk about today, exponential form and logarithmic form. On this left, you will notice that you have log b of a, and that is the logarithmic form. And on the right, you have b raised to the c equals a, and that's exponential form. Both of these are equivalent, and knowing the formats and that both are equivalent will be very important when we begin solving equations. So let's take a look at this equation. 6 times log base 9 of t plus 1 equals 4. Our goal is to get t by itself, so let's get started. Right now, we're going to subtract 1 from each side like we have with all of our other equations, linear, exponential. So we subtract 1 from each side. All of a sudden, we realize now we need to divide by 6. Remember, 6 log base 9 of t is implying 6 times log base 9 of t equals 3. Now, we divided each side by 6, so we get log base 9 of t equals 1/2. Remembering what we just saw in the other slide about transferring this into exponential form allows us to write 9 to the 1/2 power is equal to t, and the square root of 9 is 3. So let's try log base 3 of x to the 4th equals 2. We can rewrite this in an exponential form to get 3 to the second power, or 3 squared, equals x to the 4th. So we know that x to the 4th is equal to 9. If we raise each side to the 1/4 power, we get x is equal to 9 to the 1/4 power. Remember, when the exponent of x is even, it is important for us to write plus or minus in front of our answer. When we plug this into our calculator, we should get x is approximately equal to plus or minus 1.7321. In your homework and in future tests, it'll be important for you to write your answers to the 4th place value. So round at the 4th place value. Solving for the base of a logarithm. So now the exponent's not within the parentheses. You can see that it is in the base area. So log b of 81 equals 4. So we know that we can rewrite this in exponential form where the base is equal, or the base raised to the 4th power is equal to 81. When we take and raise each side to the 1/4 power, we get b is equal to plus or minus 81 to the 1/4, which is equal to 3. So let's take a look at log base b of 67 equals 5. So b to the 5th power equals 67. So we raise each side to the 1/5 power, and we find out that b is approximately equal to 2.3185. Now you might be wondering, why did we not include -3 or -2.3185? Can the base ever be negative? No, recall that we said b is always greater than 0 and b is not equal to 1. So summarizing this, for an equation in the form log b of x equals k, we can always solve that for b, which is the base, or x, which is inside the parenthesis, by rewriting it in exponential form. Now we're going to talk about the power property. Think of this as like your superpower. This gives you a lot of superpower strength mathematically to get the exponent outside of the parentheses so that we can work with it. So if you look where the red arrow is, log base b of x raised to the p is equal to, take the p outside of the parentheses, bring it in front of the logarithm, and now it implies multiplication. So p times log base b of x. Let's try some of these as we go along. Also remember that if you have two logarithms with identical bases, the items inside the parentheses are equal. So if you have log base b of a and log base b of c, a and c must be equal. So let's solve an exponential equation. So we have 2 to the x equals 12. Whenever you have an exponent that is a variable, you know that you are going to want to treat it by hitting logarithms. So we'll put a logarithm of each side. Log 2 to the x equals log 12. Now, x is in the exponent place, so we must use the new power property that we just heard so that we can bring it to the front. X times log of 2 is equal to log of 12. Now, divide each side by log of 2, and we know that x is going to be equal to log of 12 divided by log of 2, which means when you plug that in your calculator, you would see that x is approximately 3.5850. How we check this is we plug that number back in for x. Is 2 raised to the 3.5850 approximately equal to 12? Yes, it was. So putting these in your calculator can be a bit tricky. So make sure that you plug in our current problem by hitting log, and then your parenthesis will automatically come up. Hit 1, 2, close the parenthesis, then divide log, the parenthesis will come up, plug in 2, hit close parenthesis, and enter to get the correct answer. So make sure you're paying attention to those parentheses on your calculator screen. Let's solve an exponential equation. 3 times 4 to the x equals 71. Our goal, x by itself. First, divide by 3. Now, x is in the exponent, so we know that we're going to have to hit it with a logarithm. So we logarithm each side, and you can see that we have log 4 to the x equals log of 71 divided by 3. Now use those superpowers, bring the x out front, and divide by log of 4 on each side. You find that x is approximately equal to 2.2824. Check your work, and it is in fact approximately equal to 71. Now here's a warning for you. To solve some equations, you are going to have to divide both sides. So note that 3 times 4 to the x is not the same as 3 times 4 all raised to the x. So 3 times 4 to the x on the left-hand side, that x only corresponds to the 4 inside the parentheses. So you're not allowed to put that 3 inside the parentheses and make your problem simpler. You must divide that 3 away. Solving an exponential equation. Now they're getting a little bit more detailed, but think of this just like your linear equations. Try to get x by itself. So you're going to guess that we are going to add 4 to each side, and we are going to subtract 3 times 2 to the x from each side. That leaves us with 7 times 2 to the x minus 3 times 2 to the x equals 24. 7 minus 3 is 4. Times 2 to the x equals 24. Here's what we just talked about. You must now divide by 4. You cannot multiply 4 times 2. Divide each side by 4, you get 2 to the x equals 6. This begins to look a lot like our first problems. X is in the exponent's place, so we know we have to hit each side with a logarithm. Bring the x out front. Divide each by log of 2. And we find that x is approximately equal to 2.5850. Now we could do these same things by using our graphing calculator. So if you were to place 7 times 2 to the x minus 4 in y1, and if you were to put 20 plus 3 times 2 to the x in y2, graph those, you notice in the graph on the far right there is a point of intersection. That point of intersection says that x is equal to 2.5849, which is very similar to what we said. Now try solving this equation using your graphing calculator. Put 2 to the x for y1, put 3x, notice that's not raised, just 3 times x in y2. When you graph the line and the curve, you notice they intersect in 2 spots. That means that x has 2 values. X is approximately equal to 0.4578, and x is also approximately equal to 3.3132. And those are both solutions of when these two will be equal. So, I'm hoping that helped you get through 5.4. Please go work on your homework by reading the textbook, practicing your examples, looking at your answers in the back of the book, and spending some good quality time on really trying to understand that exponential functions and logarithmic functions can help you when you understand how they're equal or equivalent. Thank you so much. I hope you all have a great day.